Chapter 5 Efficiency Lesson. Linear programming or linear optimization may be defined as the problem of maximizing or minimizing a linear function subject to linear constraints. For example, the constraints may be equalities or inequalities. The main aim of the linear programming problem is to find the optimal solution. Linear inequalities in two variables represent the inequalities between two algebraic expressions where two distinct variables are included. In linear inequalities in two variables, we use greater than, less than, greater than or equal, and less than or equal symbols instead of using equal to a symbol. The solution for linear inequalities in two variables is an ordered pair that is true for the inequality statement. For example, if ax plus by is greater than c is a linear inequality where x and y are two variables, then an ordered pair of x and y satisfying the statement will be the required solution. Here is the example of using linear inequalities in two variables. Mr. Tony bought 6 kg of soybeans and 4 kg of brown sugar and paid off not more than 400 pesos. What is the mathematical representation? And if a kilogram of brown sugar is 45 pesos, then how much is the cost of a kilogram of soybeans? The mathematical representation is 6x plus 4y is less than or equal to 400. So y is equals to brown sugar, which is 45 pesos. Just copy the inequality we have. So 6x plus 4 times 45 is less than or equal to 400. After that, we will minus the 180 both sides. So it will be 6x is less than or equal to 220. Then divided by 6. So the answer will be 36.666 or 36.67. A system of linear inequalities is a set of equations of linear inequalities containing the same variables. Solving a system of linear inequalities is somewhat different from linear equations because the inequality signs hinder us from solving by substitution or elimination. Transportation problem. A problem concerns transportation methods or selecting routes in the product distribution network among the manufacturing plant and distribution warehouse situated in different regions or local outlets. In the transportation method, management is searching for a distribution route, which can lead to the minimization of cost and maximization of profit. We use three methods for solving a transportation problem, which is VAM, NWCR, and LCM. After that, we find the optimum solution by using the MODI method. When the total demand is not equal to the total supply, it is an unbalanced problem. Assignment problem. Assignment means allocating various jobs to various people in the organization. Assignment should be done so that the overall processing time is less. Overall efficiency is high, productivity is high, etc. In the assignment, problem management aims to assigning jobs to various people. We solve an assignment problem using the completer enumeration method and the Hungarian method. The Chinese postman problem, also known as the route inspection problem, was first posted by a Chinese mathematician known as Quen Meiko in 1962. A variation of the Eulerian circuit problem for underwritten graphs. An Euler circuit is a closed walk covering every edge once the starting and ending positions are the same. It involved calculating how a mail carrier could best choose his route to minimize his time. If the input graph does not contain Euler circuit, in an unweighted graph, the minimum number of edges to duplicate so that the given graph converts to a graph with the Eulerian cycle. Second, in a weighted graph, the minimal total weight of edges is duplicated so that the given graph converts to a graph with the Eulerian cycle. This is the steps of algorithm to find the shortest closed path or optimal Chinese postman route in a weighted graph that may not be Eulerian. Minimal spanning trees. A minimum spanning tree is a special kind that needs to connect all nodes to the tree in the smallest possible way. A tree has one path that joins any two vertices. A spanning tree is a subgraph of an directed connected graph which includes all the vertices of the graph with the minimum possible number of edges. Kruskal's algorithm is a minimum spanning tree algorithm that takes a graph as input and finds the subset of the edges of the graph which form a tree that includes every vertex as the minimum sum of weights among all the trees that can be formed from the graph. We start the edges with the lowest weight and keep adding edges until we reach our goal. The steps for implementing Kruskal algorithms are as follows. Sort all the edges from low weight to high. Take the edge with the lowest weight and add it to the spanning tree. If adding the edge creates a cycle, then reject this edge. Keep adding edges until we reach all vertices.